In this video, I'm going to show you how to calculate the displacement of a moving object using the velocity time graph. Okay, like other videos, the basic is here. Displacement equals area under VT graph. Now we need to know the displacement covered by the object from what point of time to what point of time. I mean, just not just displacement, but we need the time interval. So the time interval, let's say it's from 2 seconds to, let's say, 8 seconds. Okay, let's say it's from 2 to 8 seconds, right? So when time equals 2 seconds, my velocity is 9 meters per second. When time equals 8 seconds, my velocity is 6 meters per second, right? So from 2 to 8, okay, I'll just shade the area that we are interested in. And that's the area of this graph. Sorry, I should have written displacement between 2 seconds to 8 seconds. Right, the displacement between 2 seconds to 8 seconds. We are interested in the area under this graph. Okay, 2 to 8 seconds. So from 2 to 8 seconds, that's 8 minus 2, 6 seconds. Right? And from at 2 seconds, the velocity is 9 meters per second. And at 8 seconds, the velocity is 6 meters per second. So what we are interested in is the area of this trapezium. Okay, so method 1, we're going to find the area of this trapezium, which is half the sum of parallel sides times vertical height. And that'll give us 45 meters. Okay, the 45 meters. Again, the very basic is the area under velocity time graph. So when we're interested in, when we're so focused on calculating the area, we realize that there's more than one method to do this. There's more than one approach. Right, because after all, we are interested in area. So another way, which I think some of you has already seen it, or some of you are able to see it, is actually the area of a triangle and the area of a rectangle. And for the triangle, from 6 to 9 meters per second, right, this will be 3 meters per second. And this will be 6 meters per second. Okay, so for method 2, it's area of triangle plus area of rectangle. So the area of triangle will be half base times height plus area of rectangle will be 6 times 6. I'll now highlight, okay, by chance the numbers look almost the same. So I just pinpoint to you where these 6 come from. These 6 and these 6 are the same and belong to this 6. Alright. And this 6 belongs to this one. also can belong to this one. Okay. And you also get 45 meters. Okay. How about method 3? How about method 3? So for method 3, we're going to take the area of this big rectangle. Alright, the area of this big rectangle, which is here, 9 meter per second, and here is 6 seconds. Right, we're going to take the area of that big rectangle and minus off this triangle. I'm going to minus out this triangle. Right, the one I shaded in cyan. Okay, I'm going to minus out this triangle. Okay, so I have area of rectangle minus area of shaded triangle, and that will give me area of rectangle will be 9 times 6. Area of shaded triangle will give me half base times height. Okay, half base times height. Alright, and let's highlight the numbers that you need to know. 6. This is 6 and this is 6. Okay. Right, they belong to the same thing. And you also get 45 meters. Again, we take, for method 3, we just take the whole area of the rectangle because it's easier to find area of rectangle and easier to find area of triangle. We just subtract all the area of triangle. We are left with area under VT graph. And that's the displacement between 2 seconds to 8 seconds.